It's not. Oh. Oh. Okay. Sorry, I'm. Okay. Okay. I see. I understand. Excuse me. Oh, in higher. I'm going. Okay. I'm so wrong. Okay. Um. Oh dear. Hope I didn't mess anything up. Yes. Okay. That's better. Okay. Here. This obstacles you, dummy. Oh. Oh, hold on. Let's close you. Let's close you. And bring you down. There we go. In hierarchy. Read the thing. Okay. Bottom of your hierarchy. Duplicate the obstacles. Okay. Duplicate Control Z. Control D to duplicate the obstacle. Okay. Oops. Okay. Do, 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 do. You know, some people have their way. Other people have theirs. And alright, so let's zoom out and take a look. Oops. Yeah, that one is off the range. So alright, and we will delete you. And now we will move this over so you can clearly see it. Alright, and let's Let's go. I didn't save it. There we go. Boom, 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 boom. And okay, we did it. Let's move on to the next lesson. I think this is a recap. Alright, let's do the recap.
So we've made it to the end of this little lesson. To wrap everything up, we've added some really good functionality to our game now. So when I press play, see the vehicle drives down the road. It doesn't move incredibly fast. It moves. So we've made it to the end of this little lesson. To wrap everything up, we've added some really good functionality to our game now. So when I press play, see the vehicle drives down the road. It doesn't move incredibly fast. It moves at a nice normal speed. It runs into all of these boxes with physics. Because the vehicle has physics, it just drives straight off the road, which is totally okay. Be free, vehicle. We also learned a lot about coding in this lesson. We created our very first C# script, learned a little bit about the structure of how scripts and classes work. We learned about comments, even made a few of our own, learned about methods. We wrote our very first line of code and called our first method to be able to move the vehicle forward. So now we know how to use methods. We've learned a bit about parameters and how we can pass computer the information that we need to do something. We even cleaned up the way our speed is calculated a lot by making sure that our vehicle moves over time instead of once every frame. And we even learned about these cool little multiply operators. And then on our vehicles and on our obstacles, we added a rigid body component. We learned a little bit about our rigid bodies and our colliders. So now we can really create collisions for our vehicle and our obstacles. In the next lesson, we'll add some code to our camera so that we can actually follow along behind our vehicle as it drives away down the road. We'll see you there.
Okay. Mark is completed. Yay! Look at us getting all my XP. Alright. Go away. Okay, so this is going to be lesson 1-3. Ooh, it looks like there's quite a bit here. Alright, so it looks like I can complete all of lesson 1 and probably get started on lesson unit 2. But yeah, I think I could be done with well, we got like 30 minutes. Let's see what we can do for 30 minutes. Alright, so we're going to start 1-3, and we'll see what we can do. So here's High Speed Chase. Introduction.
We've successfully programmed the vehicle to drive down the road, colliding with obstacles as it goes. But the poor player is left behind, missing all the action. So by the end of this lesson, the camera will follow the vehicle down the road, giving the player a front row seat to the wreckage. In order to keep the camera behind the vehicle, we have to understand a fundamental new programming concept: variables. A variable is just a piece of information that can vary or change. And variables are critical for what we're trying to do here. Since the vehicle's position will always be changing or varying, we need a variable to track that position. You couldn't set the camera's position to a fixed number like 5, 10, or 100. It wouldn't be able to move with the car. So we'll make a new variable for the vehicle's position, set the camera's position based on that variable, and just like that, your camera will be able to stay right on your vehicle's tail. To make all that happen, I'll see you in Unity.
Okay, that was a fast one. Alright, let's zoom along. Add a speed variable for your vehicle. We need an easier way to change the vehicle speed and allow it to be accessed from the inspector. In order to do so, what we need is something called a variable. Let's add a speed variable for our vehicle.
Our vehicle now can drive all the way down the road. We have all these obstacles that they can collide with. It has a whole bunch of physics applied to it, but our vehicle still moves a little bit fast, so we want to be able to change it, and we also want to be able to see it. To do that, we're going to use something called a variable. So, in our player controller script, right underneath this first curly brace, underneath player controller, we're going to create a new line by pressing enter, and then on that new line, we're going to create our very first variable. So we're actually going to use this variable to be able to change this number here. So usually in code, it's pretty bad, especially when you have what's called a hard-coded number, because that means that if you ever need to change it, say we reuse speed for some reason ever again, we'd have to keep changing the number 20 versus we could just change the number in our variable. So what we're going to do is we're going to use the word float. Now, float is a keyword that helps the computer know that we're creating a number with decimals in it. And then we're actually going to say what the name of this variable is. So we can call it speed. And we're going to use the equal sign here. Now, it's very important. The equal sign to your code is very different than an equal sign when you're doing math in the real world. So this actually will assign our speed variable a value. So our speed will be set to whatever number we put next, and it will store that number whenever we need it. So because we are using decimals, we'll type a 5.0, so this is a decimal, and then we add a semicolon at the end, so that way we know we're at the end of this line. We are done with our statement. Now you can see that our IDE is pretty mad at us right now. There's this red underline, and it says that it doesn't understand what this 5.0 means. So actually what we need to do is we need to tell our program that this is a float, and so we add the F at the end. So now, as our computer tries to understand this line of code, now our computer knows that 5.0 is supposed to be a float specifically, so we add that F at the end. So now we have our speed variable. It's always carrying the number 5. If we ever need to, we can change it to be 10 or 20, whatever we want it to be. And so where we have our 20 in our update method, where we're transform.translating our object, we'll take out our 20 and just put speed. So now our code knows that we are multiplying by the value 5, even though we're using the word speed. So that's very helpful. So now, if we test our game, our vehicle should be moving a little slower. Not bad, so it's moving about 5 meters a second, and now it's just pushing those boxes along. Now, we want to actually be able to see this speed variable in Unity. So right now, our speed variable is a variable that belongs to this entire class. It's what we call a member variable. And right now, it can only be seen inside of methods inside of this class, and it can't be used outside of this class. Now, we can actually use the word private to denote the level of access that somebody has with our speed variable. The private keyword is what's called an access modifier. In fact, the public keyword is also an access